Hey, ninth graders, it's Mrs. Johnson. We're going to do the sequences test review. So that means I'm going to go over all the questions from the sequences test. Some of you might have thought that you did pretty poorly on it, which is probably why you're watching this retake video. All right, I'm going to share my screen. We're going to go over these problems. Here's my lovely background. Okay, so you folded up your paper like this, folded it into 4. On the back side, 7, 8, and 9, 10, share a screen. We also will be using these things. So other thing to keep in mind when you type in exponents, don't forget the parentheses everywhere. Okay, so let's look at this first sequence. We have 2, then 7, then 12, then 17. What's happening every time? Well, 2 plus 5 would give me 7. So I'm going to make a little note of this because I want to see if it's going to add 5 every single time. Well, this first one definitely adds 5. And then 7 plus 5 gives me 12. 12 plus 5 gives me 17. Now, that is an addition pattern, so we would say that this is arithmetic. Okay, since it's arithmetic, we would say that D is adding 5 every time. D equals positive 5. To write our explicit equation, this is the part where I'm going to need to show a little bit of work on my paper. I know that the explicit formula is right here for arithmetics. F of n equals the first term plus the difference times n minus 1. So I would write F of n equals the first term, which was 2, plus the common difference, which was adding 5 every time, times n minus 1. Some of you might have gotten this wrong because you typed this in. You've got to distribute and combine like terms. So we get f of n equals 2 plus 5n, and then 5 times negative 1 is minus 5. Add 2 plus negative 5, and I get f of n equals, bring the 5n to the front, 2 plus negative 5 is negative 3. So when I go to type that in, I get f of n equals 5n minus 3. And that would be my final answer. The recursive equation always starts with f of 1 equals, and then you tell what the first term is. Well, our first term is 2. So f of 1 is 2. And then this next part, yes, I did do a comma and a space. F of n is going to equal f of n minus 1. And then to say every single time I add 5, I just put a plus 5 on the end. Super simple. To find f of 8, you are going to use your explicit equation. So I go back to this equation, but instead of f of n, I've got f of 8. And that means wherever there was an n in the original equation, well, I changed colors of blue, I will put in parentheses an 8. So I've got an 8 there. 5 times 8 is 40. Plus 3 would give me 43. I was going to open Desmos, but I already did the math in my head. But I'll open Desmos just so we've got it open in the next tab. So we had 40. Oh, I said plus 3. It's supposed to be minus 3. So 5 times 8 is 40. Take away 3, and I would have 37. All right, that is all for problem number 1. Okay, let's look at problem number 2. On problem 2, we have 343, then 49, then 7, and 1. So this is clearly dropping. That drops by a ton, and then it drops down to 7 and then to 1. This is not subtraction. If it was subtraction, the numbers would be a lot closer together. So what is it multiplying by? Well, some of you might be thinking, it's dividing. Of course it's dividing, but that still has to be written as a multiplication pattern. So that means that I still have to write it as a fraction. Now, if you forgot how to do that, you can take this 1 divided by 7. You would get the fraction 1/7. You could also go 7 divided by 49. 7/49 is 1/7. And 49 divided by 343 is 1/7. So this is geometric. Spell it correctly. Geometric. R equals 1/7. You can put it in parentheses. I think I accept the answer without parentheses as well on that one. The explicit equation, well, for this one, we would say that f of n equals, and then you would have to have, go back up here, the explicit equation for a geometric sequence, you need the first term times the ratio to the power of n minus 1. So I would say the first term, 343, times that ratio, 1/7 to the power of n minus 1. Now, what I really wrote, but I had a ton of parentheses, was this. this on here. F of n equals 343 times 1/7 to the power of n minus 1. I just had to type in all this extra fancy stuff to make it work, such as the star. Technically, I think you don't have to have the star there. I typed it both ways when I accepted the key. To the power of n minus 1 needs to be in parentheses. For your recursive equation, these are always simple. Do not miss the recursive equations. You tell me what the first term is, 343, comma, space. Then you say f of n equals f of n minus 1. And then you tell me what happens. Well, this is multiplying by 1/7. That's all. Okay, you don't even need the star there. You could just say times 1/7. Okay, so how do I find the 12th term? Well, when I go to put this here, I am going to say f of 12 equals 343 times 1/7. But instead of 12 minus 1, I know that 12 minus 1 is 11. Now, I believe that when you type this in, this is accepted as one of your answers. Another thing that is accepted is you could split 343 into a power of 7. So if I go over here, I can say 7, is it to the third power? Yeah, 7 to the third power is 343. So instead of 343, I'm going to write that as 7 to the third. Now, instead of 1/7 to the 11, I could say 7 to the negative 11. That gets rid of this fraction. It puts it as a negative exponent. 3 plus negative 11, what is that? Negative 8. So 7 to the power of negative 8, which is 1/7 to the 8th power. So I would accept either of these answers, and just to prove it, I will type it this way. And if it marked it wrong on the test, I don't know if it did, but if it does mark it wrong on the test, I will fix it for you. Power of 11. I don't know why that is right there. Okay. So there you have it, 343 times 1/7 to the power of 11. But if you simplified it to 1/7 to the 8th, that is also correct. Okay, let's look at question number 3. We have -2, -8, 32, 128. This starts to grow very quickly. That makes me very certain that it is geometric. I don't actually know it's being multiplied. Well, I'll be honest. I know it's being multiplied to go from 2 to 8, and from -2 to -8. But if you didn't know, you could start at the end here, -128. And you could divide by the number in front of it, which was -32. And you get 4. And if you were to do the next one to test, you could do -32 divided by -8. And I get 4 again. That means my R value is 4. I'm multiplying by 4 every time. That makes this geometric. My explicit equation, well, remember, explicit equation always takes the first term. Here, it was -2. And then you multiply by the thing that's being multiplied, 4 to the power of n minus 1. You don't have to put the 4 in parentheses. You can put the 4 in parentheses. The n minus 1 does have to be in parentheses. There's nothing else I can simplify here. I do not want to multiply that to make -8 because the exponent is overpowering that 4, which means it is not available to multiply by the -2. Your recursive equations will always look almost identical. The first term was -2. Then you can say f of n equals f of n minus 1. And what were we multiplying by again? 4. Just going to say times 4 on the end. That is all. Okay, f of 9. Let's go back to this explicit equation. My explicit equation was f of n equals -2 times 4 to the power of n minus 1. Well, now that I'm doing f of 9, that is going to equal -2 times 4. But instead of writing 9 minus 1, I'm just going to write 8 because I know what 9 minus 1 is. And then 9th graders, I can just type this in. -2 times 4 to the power of 8. Let's say you didn't want to type it that way. What if you wanted to try typing it in here? -2 times 4 to the power of 8. Look, you get an answer. You could type in -131,072. I didn't want to type in that number because it's really big. There is a way you could simplify exponents here, but you'd have to turn this into a base of 2, and I don't want to do that, and I don't expect you to do that. So again, multiple answers you could have typed in that all equal the same exact thing. Here's what you couldn't do. You couldn't do negative 2 times 4, which gives you negative 8 to the power of 8. That doesn't work because the 4 is tied up in the exponent, so it cannot multiply by the 2. Okay, question number 4. This one, we go from 10 to 6 to 2 to negative 2. This is subtracting 4, so D equals negative 4. I don't know why I wrote the letter F. That was weird, but that makes this arithmetic. The explicit equation. Remember, when it's arithmetic, you have to do the dirty work to get the explicit equation. So let's go with f of n equals the first term, which was 10, and then I'm adding the thing that is our common difference. Ours was negative 4 times n minus 1. All right, I'm going to distribute this negative 4. So I have f of n, and the 10 stays the same here, but negative 4 times n is negative 4n. Negative 4 times negative 1 is positive 4. So f of n equals, I'm going to bring the negative 4 to the front with that n because our variables always come to the front. 10 plus 4 is 14. Okay, now this is asking for the 54th term. So f of 54 is equal to negative 4 times 54 plus 14. I don't know what that is, so I'm going to type it into my calculator. All right, f of 54. Negative 4 times 54 plus 14, and I get negative 202. So I could write negative 202. Beautiful. Let's type that in. Oh my gosh. Do you notice that I skipped this step in here? I just went right into that last part. But what I want to type here is I want to actually type the explicit equation, which simplified is right here. Okay, so we have f of n equals negative 4n plus 14. Now the recursive equation, they're always so similar. They start with the first term, f of 1, and our first term here is this 10. Then comma space, you have to do the second part of the equation. Second part of the equation is almost always identical. F of n equals f of n minus 1. And then what were we doing every time? Well, our common difference was negative 4. So we were adding a negative 4. Instead of writing plus negative 4, I'm just going to write minus 4. Okay, that is all for question number 4. Number 9, upload a photo of your work. Cheating is gross. Don't be gross. Okay, number 6 and 7, stop missing these. These are so simple. Given the first term and the recursive formula, generate the first 5 terms. I want you to realize why the recursive equation can be helpful. What is your first number? Right here, 21. Okay, what are you doing every time? You're adding 6. So what's 21 plus 6? 27. Okay, so what can I do here? Well, I did 21 plus 6. Okay, now I can do 27 plus 6. And then I can do 33 plus 6. And I can get all these terms. So I've got 21, 27, 33, 39. Plus 6 would give me 45. Hopefully I did that math right. I'll find out at the end when I submit it. Okay, looking at this next one, I gave you the first term in the sequence, which is 5. And then it tells you that you are multiplying by 2 every single time. Well, 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. And 40 times 2 is 80. Brooklyn? Sorry, my kid's over there being kind of loud. Okay, question number 8. You are selling coupon books to raise money for your soccer team. Wow, good for you. On the first day, you sell 8 books. I'm gonna write that down, 8 books. You set a goal to sell 3 more books the next day, 3 more books the next day, and so on. So 8, well, 3 more books would be 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. I hope that was the last one. It was not. And then 26. So filling in this table, super simple. Okay, so use that table to complete the following. What is the recursive function? So f of 1, well, our first term was 8. Then comma space, f of n equals f of n minus 1. And then what was I doing every time? I was adding 3. That's all. Now our explicit equation, since this is arithmetic, I'm going to have to write an equation and then simplify it. So I would start with f of n equals, and the first term was 8. Now remember, we were adding 3 every time, and we have to multiply that by n minus 1. So I'll distribute this. I've got f of n equals 8 plus 3n minus 3. I can combine 8 and negative 3. So I get f of n equals, I'm going to bring the 3n to the front, and then 8 minus 3 is positive 5. So there's my explicit equation. F of n equals 3n plus 5. Yes, you had to simplify. Okay, so if you want to keep up your goal, how many coupon books will you have sold on the 10th day? So I am going to go to the next line and I am going to say f of 10. And then I'm going to replace this n with a 10. 3 times 10 plus 5. Well, 3 times 10 is 30, plus 5 is 35. So that would be on my 10th day, 35 coupon books. Okay, on the 20th day, what will it look like on the 20th day? Well, we can put that over here because I kind of ran out of space on the bottom there. F of 20 is 3 times 20 plus 5. Well, 3 times 20, 20, 40, 60 plus 5 is 65 coupon books. Yes, you could use a calculator to figure that out. And then we can go to the 30th day. On the 30th day, f of 30, we would have 3 times 30 plus 5. Well, 3 times 30 is 30, 60, 90. 90 plus 5 is 95. So 95 coupon books. And that's all you're doing for that arithmetic equation on problem number 9. Let's look at number 10. You are watching some bacteria in a microscope. Gross. After the first hour, there are 16 bacteria. So I'm going to write that in here. After the second hour, there are 32 bacteria. And the bacteria continues to double every hour. So we double 32 and get 64. And then I'm going to just not count on my mental math after that. 64 times 2 gives me 128. 128 times 2 gives me 256. So I have 128, 256. We need 2 more. 256 times 2. And 512 times 2. Okay, so 512 and 1024. Okay, let's write a recursive equation. We know that the first term was 16, so f of 1 equals 16. Then we can say that to find f of n, you do f of n minus 1, and then remember we were doubling every time, so you could say times 2. Or you could do parentheses 2. That's the same thing. The explicit equation here, well, when we are doing explicits on these, we don't have to simplify because you're not simplifying these exponents every single time like you would with distribution. So we would say f of n equals the first term, which is 16, and then we are multiplying by 2 to the power of n minus 1. So when I type that in, I have f of n equals 16 times 2 to the power of n, parentheses, n minus 1. Okay, so if they continue multiplying at this rate, how many bacteria will be there after 12 hours, after 24 hours, and after 48 hours? So I want to remind you how you can do this. We are going to start with the 12 hours. So I can say f of 12 hours equals 16 times 2, but instead of n minus 1, I'm going to do 12 minus 1, which is 11. For the next one, I can say that f of 24 equals 16 times 2, but instead of the 24 minus 1 hours, I would say 23 hours. And then for the last one, we've got f of 48 equals 16 times 2, but instead of 48 minus 1, we'd have the 47 power. Okay, so let's see what we got here. Let's type these in. Now, yes, you could type in on your calculator 16 times 2 to the 11th, and you would get an answer right here. You could type in 3,276 or 32,768. If you type in 16 times 2 to the 23rd power, you even get a number that works. But when you try typing in the last one, you do not get a number that works. This is scientific notation, which means you have to type in the exponent form, because on your test I said I will not accept scientific notation. So you can say 16 times 2 to the power of 11. You can say 16 times 2 to the power of 23. And you can say 16 times 2 to the power of 47. And then you can also, if you wanted, 16 can also be written as 2 to the 4th power. So what is a different way that we could simplify all of these? Well, if 16 can be written as 2 to the 4th, hold on. If 16 can be written as 2 to the 4th, we could write this as 2 to the 4th times 2 to the 11th. Well, 11 plus 4 would be 2 to the 15th power. On the purple one, I could say 16 is 2 to the 4th, so 2 to the 4th times 2 to the 23rd. And when I combine those, add those together, I would have 2 to the 27th power. And for the blue one, 16 could be written as 2 to the 4th, and then we have 2 to the 47th, 48, 49, 50, 51, so we could have 2 to the 51st power. I can't remember if I accept the first version when I wrote this, but just know that when I graded it by hand, I would accept it. But these are the final simplified versions. Again, just so you can see them there. I'm going to try submitting without that final simplification, and let's see what happened. Okay, number 12 was uploading the work. There's extra credit. Those of you who tried it in class got it. If you did not try it in class, or if you're online, please email me and I will talk to you about it, or email Mr. Bodley if he's your math teacher. Okay, let's try submitting this and let's see how we did. I'm kind of nervous whenever I submit these because like I'm doing this live. It looks like I got 34. Holy smokes. Let's see what I got wrong. This one. Ugh, how annoying is that it won't tell you what you got wrong? Super annoying. Okay, so there was something on problem number 2 that I got wrong. Something on problem number, oh, that one's fine. Just number 2 so far. Apparently a lot. I'm guessing all 3 of these were wrong. But when I go through and grade them, just know I'll give you partial credit for those, so don't panic about that. And then I obviously didn't get points for that. I'm gonna push pause really quick and see what I got wrong on problem number 2. Geometric, r equals 1/7. Okay, let me pause this quick. Oh my goodness, if I can. Okay, I see what I did wrong. It's marking this one wrong, but if I did, when I graded your test by hand, I give you points for that. It's because we didn't focus as much on simplifying that 343 this year, so don't panic. Again, I would still mark that correct. All right, wonderful luck on your retake. Let me know if you have any other questions.